Lesson 11, Pythagoras Theorem. So what Pythagoras Theorem is, it deals with right angle triangles. And so our first definition here, right angle triangle, all you have to know is when you're looking at a right angle triangle, it has to have in it a 90-degree angle. And we often represent that 90-degree angle by a little box in the corner there. So you can see, yeah, this is a right angle triangle, so we can use Pythagoras Theorem. Okay, there's two more definitions here. The hypotenuse. The hypotenuse is the longest side of the right angle triangle. So hypotenuse in this case is C, and you can use any letters you want. We normally use A, B, and C for Pythagoras Theorem, but you can use anything you want. And if you look, you see this box here? It's across from the longest side. It's always going to be that way. And then we have legs. The two shorter sides, A and B in this case, right, are known as legs. And again, you can use any variables you want. Okay, so the standard Pythagoras Theorem, here it is if we take the square of the longest side, take whatever the number is. If it was a 10, we would square it, would be 100. It's equal to the square of the two shorter sides added together. So if you're looking for the longest side, you always take the two shorter sides, square them, and add them together. Now, what if you're looking for one of the shorter sides? Well, to find a shorter side, you take the longest side, the hypotenuse, square it, and subtract the other leg as a square of it. And if you want to find that one, then a squared equals the hypotenuse minus the other leg. So those are just the basic formulas. It's just variations on c squared equals a squared plus b squared. We just rearrange them. Now, the key thing here is this only works for right angle triangles. So if your triangle is not a right angle triangle, if it doesn't have that box in the corner, you can't do this. Okay, go to the second page. Let's prove that the Pythagoras theorem is correct. So we have a standard triangle here, and these are not to scale. I mean, you can see the lengths are a little bit off here. So we label our triangle. There's our right angle. Across from it is C. C is 5. Our two legs are 3 and 4. And it doesn't matter. You could label this 3 as an A or a B. It makes no difference. It'll work. So here's C squared equals A squared plus B squared. So let's plug in the numbers. So 5 squared, that's the hypotenuse, equals 3 squared plus 4 squared. So 5 squared is 25. 3 squared is 9. 4 squared is 16. 9 and 16 is 25. Yeah, we proved that. Look right there. The hypotenuse, the square of the hypotenuse, is equal to the square of the two shorter sides. And again, right angle triangles. So you're never going to get a question like that. There's always going to be a question like, okay, here's two sides, find the third. And you're either going to find the hypotenuse or find one of the legs. So let's look at this one here. So we got a triangle. We got C. They label as C. It's a right angle triangle, box in the corner. A and B, it makes no difference which one we label them as. We're looking for C. We're looking for the hypotenuse or the longest side. So our formula, C squared equals A squared plus B squared. Plug it in. So A is 17, B is 11. So just work your way down. So 17 squared is 289, 11 squared is 121. Take those two and add them together. Now, we're not done here because that's C. Oh, that's really big side. No. You have to take the square root of it. C has to be by itself. So what's the inverse operation of squaring something? Well, taking the square root. So if we take the square root of C squared, we end up with just C. So then we take the square root of the other side. We end up with 20.248. Keep going on forever. We'll round to 1 decimal place. So if we round to 1 decimal place, if you remember, hey, we're looking to the tenths here. So we look at the 4, it's less than 5, so we keep that number the same. If it was 5 or greater, we would round that up to 3. Okay, so that's finding the hypotenuse. Flip to the last page now, and we're going to look for the legs. So in this case, we have a right angle triangle. Again, look, there's our right angle, right? We have the hypotenuse in this case, it's 29, and we have one of the legs. And this one, since this one's already labeled A over here, we'll call this one B. So B is 17. Now we're looking for the shorter side. So we're not going to add them together. We're going to subtract them. So it's A squared equals C squared minus B squared. Again, plug in the numbers. So A squared equals 29. That's the hypotenuse, 29 squared, minus 17. That's B, 17 squared there. So we end up with A squared equals 841 minus 289. Do the math. Subtract them. We end up with A squared equals 552. Now, again, we're trying to get A by itself, so we do the inverse operation. So the inverse of squaring something is square rooting. So square root, left side, square root, right-hand side. And of course, you grab your calculator and do this. So A equals 23.4946. And again, we're going to round to 1 decimal place. So we look at the 4, we go 1 number to the right, and we see it's a 9. So that's going to round that 4 up to a 5, so 23.5. Okay, last example here. It's a right angle triangle. We have the hypotenuse across from it. We're looking for B, one of the legs, and we have the other leg, so A. Okay, so B squared equals C squared minus A squared. We're subtracting because we're looking for one of the legs. So B squared equals 13 squared minus 5 squared. b squared equals 169 minus 25. Subtract that, we end up with 144. Again, b squared, we want b by itself, so we do the inverse operation, which is square root left side, square root right side. And this one works out really nice. B is 12 because the square root of 144 is 12. And this is actually known as a Pythagorean triple. What we're talking about with triples is, for instance, it was 5, 12, 13. They're all nice whole numbers, no decimals at all. The main example when we proved it back on the second page was a 2, 3, 4. Sorry, that was a 3, 4, 5 triangle. That is also known as a Pythagorean triple. Okay, so that's Pythagorean theorem. Now you can work on practice 11.